Okay, so yesterday we started with the basics of Terraform, where we try to understand about um, how your file should be constructed, what should be the extension of your file, and how the blocks should be written, what is blocks, and inside your blocks, how the argument and value should be written, and what is plugins, what are the different types of, what are the different plugins available, and what's the use case of the plugins, and what is the workflow, like writing a configuration file, then planning it and applying it. So all these things we saw in the yesterday's class. So yesterday I talked about one particular thing called state file. So let's see state file in detail today, which is pretty important.
Yes.
Okay, so let me just first talk about this. So what is state file, right? So let's assume that you are creating a configuration file. So Terraform configuration file. Let's assume that you are doing it on Monday. Okay, so on Monday, you're creating a Terraform configuration file, which supposed to create EC2 instance, and the EC2 instance size should be T2 micro. Now what you're going to do, you're going to perform Terraform apply. When you do Terraform apply, your Terraform is going to connect with the cloud platform, and it is going to create the EC2 instance, which is fine. So this is what we saw yesterday. Okay. So the other part which we didn't see is after creating the EC2 instance, Terraform is going to capture all these EC2 informations into a file. And this file is called as Terraform state file. And this file is auto-generated file. This file will be generated by Terraform itself, and the format of this file is going to be JSON. JSON is a file format. Okay, so you are creating a configuration file. After you do Terraform apply, it creates a resource, and once after the resource creation is completed, it is going to create a JSON file, auto-generated JSON file, which is called as Terraform state file. Okay, so now what exactly this state file is created? What is the purpose of this state file is getting created? The state file is eventually going to allow us to enable idempotency. What is idempotency? Anybody heard about this word called idempotency?
No.
Okay. So idempotency is a mathematical word. So what it means is you can try to perform some action multiple times, but the result will be same. For example, 1 into 0 is going to be 0. How much ever time you just multiply this, the answer is going to be 0 only, right? So basically what it says is you can try to perform a particular action 100 many times, but the action's result is going to be same all the time. Okay, so we are like HashiCorp is trying to enable idempotency with help of the state file. Now, for example, this code is created by you on Monday, and you perform Terraform apply, and it created the EC2 instance, and JSON file is created. Henceforth, how much ever time you do Terraform apply of this configuration file, Terraform is not going to go and create the EC2 instance again and again, what you referred in your configuration file. If that is happening, for example, you have 10 people in your team, all the 10 people are going to perform Terraform apply on this code, it will end up in creating 10 different EC2 instances. We don't want that to happen, right? So that's where this idempotency comes into picture, and that's where the state file also comes into picture. So henceforth, for example, on Tuesday, okay, so Monday, let's assume that Aruna created this configuration file and she performed Terraform apply. EC2 instance is already created. Now, Aruna is on leave on Tuesday. Now, Shashank need to, Shashank does not aware of the code is already executed and the EC2 instance is created. For example, Shashank is again trying to perform Terraform apply on this code. What will happen? Terraform is not going to go and create one more EC2 instance. Instead, before going to AWS, it is going to first read the state file and try to compare the configuration file with the state file, whether this particular resource is matching with the state file or not. If it is matching with the state file, it is not going to go and recreate the same, create the same sort of resource again in cloud platform. Okay, on Monday, Aruna created the configuration file and she pushed the code to GitHub. Okay, and she did Terraform apply also, resources created, state file also created. Now, on Tuesday, Shashank is not aware of that it is already done. He is trying to clone this code to his laptop and performing Terraform apply. If idempotency nature is not there, it's supposed to create one more machine, but idempotency is enabled with help of state file. Since state file is already there in place, your configuration file is going to first read the state file, and it understands that already EC2 instance is there, so it is not going to recreate it. So this is what idempotency is all about. You can apply this configuration file 100 many times, but it is going to perform that action only one time. The EC2 instance will be created only one time. Now on Wednesday, like Aruna is back and manager is telling that the machine need to be upgraded from T2 micro to T2 medium. Okay, the machine is created with T2 micro, but the machine is super slow. Okay, so it has only one CPU and 1 GB of RAM. So the application is pretty much throttling. Okay, so application is not working fine because of very less number of CPU and memory. And manager is telling Aruna, can you upgrade the machine? Now Aruna need to upgrade the machine from T2 micro to T2 large. Now what she is going to do, she is going to go to the code and she is going to update the code from T2 micro to T2 large. Once she completed upgrading, modifying the code, she is going to perform Terraform apply. Now Terraform again is going to read the configuration file and compare the configuration file with the state file. In the state file, it is going to say that the machine is currently running with T2 micro. In your configuration file, you updated from T2 micro to T2 large. Now Terraform understands that the real-time machine is running with T2 micro, you're trying to upgrade to T2 large. So Terraform is going to perform only that change on the existing machine. It is not going to create new machine again. So all the remaining configurations are matching with your machine. So it is not going to recreate anything. Instead, it is going to just simply update your machine size from T2 micro to T2 large. And once after that particular process is done, the real-time resource is upgraded to T2 large. Again, it will update the state file with the updated information. So the machine size is updated to T2 large. That will be updated in the JSON file also. Now your configuration file, JSON file, state file, and real-time resource, all three are matching. So in configuration file also T2 large, state file also T2 large, and real-time resource also running with T2 large. So assuming you can think like the state file is going to be the link between your configuration file and the real-time resource. You guys understand what is state file?
I have one question. If suppose a config file and state files are not similar, so it is going to create new mission.
If the config file and state file is not similar, it
Hmm.
is going to update only whatever the discrepancy is. For example, in your configuration file, the machine size is saying T2 medium, and in your state file it is saying T2 micro. Then it is going to start updating the machine to what you mentioned in your configuration file. Okay, we'll see that practically. I'll show you how this works. You'll get more understanding on that.
No, my doubt is if suppose two developers will do changes differently. So the
Mhm.
at that time, this state file will be differ, right?
There will be only one state file, not multiple state files.
Okay.
Okay, so every time, and also, like for example, multiple people are trying to perform changes at single point of time. Terraform has a concept called state locking. What is a state locking is when you try to perform Terraform apply, so it will lock, like for example, Aruna is performing apply now, and it will create a lock. Until Terraform apply completes, the lock will not get released. So let's say at the same time Sashank is trying to perform apply, Terraform is going to simply say Terraform apply is already in progress, wait for it to complete. Now once after Aruna completes, Aruna's changes are implemented, then if Shashank triggers Terraform apply again, then that change will be imposed. So that's how it avoids collusion. Is that what you asked?
Yes, yes, same question.
Okay. So we'll see that. So let me log in into the machine first. Just give me a moment. Okay, so let's go to one particular example here, two. And in this folder, I'm gonna remove the state files. And I'm gonna have only main.tf file. Let me go to the main.tf file. So this is my main.tf file. So Currently, for your understanding, so I'm going to keep the name of the machine, the tag of the machine. So additionally, so in the previous example, like we saw only three arguments in resource block. So in provider block, I am keeping everything same: access key, secret key, and region. Nothing changed here. In the resource block, everything is same. AMI and instance type is same. But additionally, I have added a new line, which is to create a tag for my machine. The tag name is MySQL database 01. So when the machine is created, you will see the tag added for this machine. Okay, so currently this machine is not exist in my console. So you can see here instance, and I have only one instance running here. That's my Terraform machine, which I logged in into. So I'm gonna do Terraform apply. So which basically should create this machine. So before do that, let me stop this. Okay, so here, when I do ls, you can see I have only main.tf file. I'm going to open one more tab to show you guys about that locking, which I talked about. Okay, so sudo su and sudo terraform example2. This is where we were going to run. So ls-al, so you can see, okay, there is a log file. I'm going to remove that. Okay, so it will automatically generate again. I'll show you how it is. Okay, so now ls-al. Okay, so that file is not there. Now when I do terraform apply, you should be able to see. Okay, so there is a command called terraform initiate to just get rid of this log dependency, because I interrupted the terraform apply, right? So the log file got generated. I deleted the log file, but still it is not releasing that. So I just run what it's asked for. Now I'm doing terraform apply again. Now at the time of terraform apply, you should be able to see there is a log file which will automatically create here. You can see here the state log. This is what I was talking about. So this state log will be available until the apply is completed. Okay, so I'm just going to say yes here. So this is going to create a machine, and let's go to console and see if the machine is getting created. Yeah, you can see MySQL database 01. That's a machine which is getting created, and the apply is completed. Now if I do ls-al, the log file automatically disappeared. So you see here there was a log file, and that file is disappeared now. But there is a new file which got created now, which is my terraform.tf state file. Now I'm going to do cat to this file, and you can see all the information about my EC2 instance is captured in this state file, and it's a JSON file. This is what we were talking about. So this file, once the machine is getting created, it will automatically capture all the machine information, and it will be available in the same folder where I was running Terraform apply. Okay, so now let's assume that I'm going to perform Terraform apply. What will happen?
Uh, it will do nothing because we haven't changed the code yet.
Right. So I am doing Terraform apply again. So basically it should not do anything because there is no code changes. And you can see here my infrastructure configuration file is just matching with my state file. and it's not doing anything. So it simply says your infrastructure matches with the configuration. Now what I'm going to do, I'm going to make some modification in my code. I'm going to perform a tag change here, which is database 01 to database 02. That is a change which I wanted to do. And now if I go back, so once after apply completed, this name should be changed from 01 to 02. Now let's do Terraform apply and see what happens. And you can see here, Terraform is trying to only trigger an update in place, which is from database 01 to database 02. Rest of things are just going to be as it is. You can see 0 to add, it is not going to add anything. It is not going to destroy anything. It is just going to simply make one particular change in the existing resource. And once after that is completed, your state file will automatically get updated to the newer change. Okay, I'm going to say yes here and let it complete. You can see it is modifying one changed and it is very immediately happened. And now you can see the machine name should be changed from 01 to 02. And now if I refresh, if I just do cat to my state file, and you can see my state file is updated to my new tag name. Now one more file would have created, which is terraform.tfstate.backup. So what is this file is about? This file is my n-1 file. So before updating the state file with the newer changes, Terraform will automatically create the backup of existing state file with .backup extension. So every time when you perform Terraform apply, before it updates the state file, it creates a backup. Okay, but when you are maintaining your state file locally, it can't maintain multiple backup files. Only it will maintain only one backup file. For example, now I'm making one more change from 02 to 03. Now the state file will be updated to 03 and my backup will be, my previous state file will say 02. But I'll be losing my first change, which is 01. I might not have the backup because locally Terraform has a limitation of maintaining only one backup, which is n-1. So it will not maintain multiple backups. If you are maintaining the state file in different location, for example, in our training, we are going to see how to keep our state file in S3 bucket. So in that time, we will see how to keep the state file in S3 bucket. So when you're maintaining your state file in S3 bucket, there is no any limitations. Okay, so it can maintain multiple backup copies of your state file. Why these backups are required? This can help you to understand the historical changes of your infrastructure. Like what was your machine configuration when it was created and what was changed and what's your current configuration. All these things you will be able to understand as an historical change from your state file.
So if we delete the state file, then next time if we run the apply the change, then will it create newly create the thing or machine, or it
Come
will
again. Come again.
if we delete the state file,
Mm-hmm.
then next time if we run the command apply terraform apply,
Mm-hmm.
then will it perform from the first, uh, will it perform all the command, or it will go for the state backup file?
Okay, good question. So when, for example, this file is deleted for some reason. Okay, so this file, let's assume that by mistake you deleted this file. Now, Terraform will not consider the backup file. Okay, when you try to perform Terraform apply, Terraform will try to go and create the new resource from the scratch, which means that the old resource, the old EC2 instance, whatever you have created, that will still running. It will not disturb that machine, but that machine will not be managed by Terraform anymore. That is more like a orphaned machine which is running in your AWS account. It will leave that machine because that machine, it does not have any track of that machine. So it will create a new machine and it will generate a new state file. Okay, now coming back to your question, what if I wanted to use the backup file? So if you're fine, for example, you already have a machine running, which has and you have your state file is missing now. You're okay to go back to the previous version of your machine. If you go back to the previous version, probably your machine might be reconfigured with the previous configurations. So if I use my previous file, what will happen? The name might be changed from 0102 to 01. This is a simple change, but at the real time it might be different, maybe machine size or machine key, something it could be. So if you are okay with that particular change, what you can do, you can simply rename this terraform.tf state of backup into terraform.tf state. So when you do that, so you will have a previous n-1 state file. So but that is not a recommended thing to do. But in a worst case scenario, if you wanted to use the previous backups, you can try to do it. So mostly backups are predominantly used for comparing and getting to know the historical changes of your infrastructure.
Yes, I got it. Sir, if a machine goes to the orphan state, means if the state file is deleted, then machine will go to the orphan state. Okay?
Yeah,
In, uh, in that purpose, if we have to delete the machine, then we have to go or do it manually through the
correct.
browser.
You need to do it manually, but there is an option to manage that machine again through Terraform. For example, I'm going to delete the state file now. Let's try out the scenario. Terraform.tf state. Now the state file is deleted, and let me delete the backup file also. Let's not get confused here. So I don't have any state file right now. I just have main.tf file, and now I'm going to do Terraform apply, which basically is and deleting the state file is not going to delete my machine. My machine is still running here. Okay, MySQL database 02 is still running here until unless I perform Terraform destroy, the machine will not be deleted. But now the machine state file I lost. Now when I do Terraform apply, Terraform is going to consider this as a new change. You can see it is trying to consider this as a new change, and it is going to create a new machine from the scratch, one to add, zero to change, zero to destroy. All right, so now how to deal with this kind of thing. So that's where Terraform has an option called Terraform import. Okay, so you can go to any official documentation. For example, let me Google like Terraform AWS instance, and this is the official resource. We talked about this yesterday. If you scroll down, every official documentation, they would have given about import. Okay, so you can use this. So I'm going to do that now. So let's do cat main.tf file. So Terraform import, and let me just make it a bit smaller here. Terraform import and AWS underscore instance. So the machine is orphaned right now. That's not managed by Terraform anymore. Now we are going to make this machine again tracked by Terraform. That's what we are trying to do. So AWS instance dot the block name. First machine is the block name and space. Go back to the console and get the machine ID. Instance ID. Come back here and put your machine ID. And now when you do run this command, it will automatically generate the state file, and post that you will see the state file. So you're just basically importing the real-time configuration of your machine. So import successful. Now come back here and do ls. You see the state file is generated, and if I go to cat tf state file, should be able to see all the information about my machine. again, and now I go into Terraform apply. So I'm not going to see the apply. It is not going to attempt to create the machine again. You got your answer?
Yes, sir.
So Terraform state file is very important in terms of interview purpose. People might ask you questions like, what will you do if the Terraform state file is deleted, which is exactly what we saw right now. You can use Terraform import option to import your real-time resource and generate your state file. And people might ask you what's the use case of Terraform state log, and they might ask you the difference between Terraform state file and backup file, and locally how many is there any limitations for your backup file. They might ask you that questions, and they might ask you about Terraform backend, like how to push your state file to a remote backend like S3 bucket, which we are going to see in the next set of examples. Like I'll show you how to push your state file to S3 buckets. Okay, so that's something which we can see. So yeah, so a lot of scenario based questions. There are option to ask a lot of scenario based questions in state file concept.
Sir, can we consider this as an advantage for like no case thing?
Come again?
Can we take this thing as an advantage for like no cats? We use like no cats from the previous state.
I'm not getting, sorry.
Uh, if we get some error from the previous machine and we want to create a fresh machine,
Okay.
like in some command we use no cats,
No get.
cats, cache, cache memory.
In Linux, you're saying?
Yes, yes.
I'm not sure if I used that command. So what exactly it used for?
In Docker, when we create image, then we use sometimes we use no cache. Sometimes in Docker file, if we create a machine and something errors goes on, and next time we want to create the image, then from the uh, previous machine, it takes automatically and creating the same error again and again. Then we use no cache.
You're talking about like you're comparing that with the item potence thing. What I'm saying.
Yes, yes, sir. Because once a machine is created and it's something, it's if it is creating some kind of error while creating.
It doesn't create any error.
Okay.
Maybe I'm afraid if I understand your question fully. So yeah, probably like I'm not understanding. That's my my problem. Okay, so maybe you can type the command in chat what you're talking about.
Okay.
Let me try to see.
So in can we take deleting a state file as a in some part like as a advantage for us?
Deleting a state file is not an advantage, right? So accidentally if you delete a state file, so then your infrastructure is something which is orphaned, what I mentioned. So in that case, so Terraform import can be useful for you to generate the state file again, right? So deleting the state file is or it is not something which people will do purposefully. It might be probably like by mistake.
Okay. Suppose, sir, we have created a machine. It was running. Mm,
Okay, yeah. So before you go back to the question, so guys, yeah, that's about state file. So yeah, so probably the next set of topics we'll see tomorrow. So yeah, so I'm just opening the floor for questions. So feel free to ask questions. Yeah, so that's about state file. So whatever I wanted to cover in state file, I covered. So yeah, now you can talk about. So I'm going to go and do Terraform destroy now. So before you ask me the question, so this is going to again read my state file and it is going to destroy the machine. And once after it is destroyed, it is also going to make my state file empty. Okay, so yes, I'm going to destroy. So you can see the machine is getting shut down and destroyed. And now like yesterday we saw, right? So when you destroy, we kind of got all the informations here. And I was telling you, I'll tell you tomorrow how these informations are available right now. These informations are coming from state file. Okay, so before when you do Terraform apply, so many of the things are simply showing as known after apply. That time Terraform does not have this information. But when you do destroy, it almost has all the informations because it is available in the state file. It captured things in the state file. Now the machine is getting destroyed, and ls you can do cat terraform.state. So currently still it is destroying. After it is completed, you will see the file will be empty. Let it complete. Okay, so it's done. Now cat, and you can see the file is empty. Nothing is there. Yeah, go ahead with your question now.
Suppose we have created a machine and it is running nicely, and suddenly the machine is showing some kind of error.
Okay.
Then next time with same configuration, same name, we need to create another. We need to create the machine,
Mm-hmm.
that machine. Then can we delete the main? Not can we delete the state file and run the
Instead of
command?
deleting the state file, you can go and delete the machine which is corrupted. Right? If the machine is not available in the AWS console,
Yes.
even if your configuration file and state file has the information, and if there is no machine available in the console, it will try to go ahead and create the machine again.
So in that scenario, we will use Terraform destroy and
You don't
again.
need to do Terraform destroy. You can directly go to the console and delete the machine. Okay, once the deleted the machine. So always you need to think in this way. So all the three things should match for Terraform. One is your configuration file, one is your configuration file, and one is your state file, and one is real-time resource. Okay, so your configuration file has a code, and your state file also has all the machines. Now you're saying there is a machine running which is created out of this configuration file. Now this machine has some issues. The machine is corrupted. Now if you go and deleted the machine, after that you come back and do Terraform apply without destroy. Terraform will go and check the state file. Now state file is going to see if it is matching with the real-time configuration. That time it understands that the machine is not exist anymore. Then it is Terraform apply will basically go ahead and create the machine again. You got the answer? Okay, so you don't need to do Terraform destroy. You can also do it manually, worst case scenario. But the best practice is to do Terraform destroy and then do Terraform apply directly from where you're running Terraform. That is a better way to do. But unfortunately, you delete it directly from the console. But still, you can do Terraform apply. Terraform understands that real-time resource is deleted, which is not matching with your configuration file and state file, and it will go ahead and create a new machine with the same configuration, and the state file will be updated again. Now everything will be matching your configuration file, state file, and the new machine which is created.
Sir, I have one question.
Yeah, good.
Sir, in the TR file, how we can configure the key pair, sir? Because in last session you told that we can't access the machine because we didn't configure that key pair. So how do we configure that key pair in TR file?
Yeah, so okay, so that is pretty simple. Anyway, I will be talking about it, but since you asked, I'll just simply show you how to do that. So in your configuration file, so it's pretty simple. Like go here and look for the argument here. So there is an argument called uh, so these are the supported arguments, right? So what are the arguments which is supported? If you scroll up, you'll be able to see all the arguments which are supported. So there you can search for keys. Where is it? Where is it? Where is it? Where is it? Mm, argument reference there. Yeah, key name. You can see here there is an argument called key name. Just copy it. Go back to your code and just put it here. Key name is equal to, and whatever your key name is. What is my key? I have it here. So I have a key called demo and icon key. Copy that and put the name of the key here, and you're done. So the machine, whatever it is going to be created, which will also have this key attached. Is it what you're asking?
Yes, sir. Thank you.
Okay.
I have a question. If we make changes in the infrastructure directly through the console, will that be reflected in the state file?
No, it will not. So that time only you can use either you can go and manually change your configuration file, which is in line with your real-time changes and perform Terraform apply again, which will update your state file. If not, you can delete your state file and you can perform Terraform import to generate a new state file, which has updated information about your manual changes.
Oh, okay.
Okay, but it is generally not recommended to do manual changes when you're using Terraform, but in worst case scenario, because when you have a big team, like when you have some production issues or something, people often will try to do all these things. But to mitigate all these things, the better option is Terraform import. Generate a new state file with Terraform import so that all the new changes will be uh, imported into your state file. Then according to that, you also need to modify your configuration file. That's a bit of uh, what to say, uh, very bad situation, bad work to do, and it's not a right way to do. These are all like to mitigate the scenario, but the best way to do is just handle everything to Terraform. That's it. But accidentally you are making some changes or deleting the machines. For all these things, Terraform has an option to mitigate. But those things you need to use only at the worst case scenario.
Okay.
If suppose if you'll change in block 2 or 3 4, any changes or any errors we got in block 2 3 4, again we have to do from starting.
Any changes in what?
Changes, otherwise any bugs will find out in block 2 or 4.
Mm-hmm.
So how we can we will make changes, we rectified that bugs, and again we need to do from starting. like
This is not
Terraform.
like okay, so I understand you're talking from a programmer perspective, but it doesn't work in that way. So when you write a code, if your code has some problems here, because here you are just writing a code with a predefined plugins and arguments. Here you're not writing anything innovative here. All these arguments, whatever available in official documentation, only that you are using, and also with the predefined plugins. So apart from this, let's say if you are defining anything which is not in the official documentation, or not something which is allowed by SHICOP. So when you perform Terraform plan or apply or any command, it will just simply throw an error. It will not allow you to progress, and then you found a bug and come back and try to fix it. That doesn't work in that way. So it will not work only. Because basically you're writing a script here. You're not writing a program. If it is a program, so you will uh, try to understand the use case, and you will try to create a logic. You will write a logic to perform something. Probably that might have a bug, because you are just following the programming standards, and you're executing it and things are working fine, but you're finding problem in your functionality what you developed. You go back and try to fix the bug, like probably like you wanted to fix your conditions or your functions, whatever. But we don't do all these things here. It's just a script, and it has a predefined arguments what it is already there in the official documentation. Just use it and write a code. If you're writing anything wrong, it's not going to execute only.
Okay.
Is that you got your answer or still confused? Your okay says you're still confused, sort of.
Yeah, little bit confused. Okay, let me try once this scenario. I will create 2, 3 blocks and let me throw one error.
Sure, sure. Yeah, try it out and let me know how it
Hmm.
works.
Yeah.
So to see the bugs, uh, we can use the command. We can use one command to check whether the file is uh, okay or not.
Terraform validate.
Yes, yes, sir.
Yeah, we saw
Okay.
yesterday. Yeah, that's the command. So, but what I'm trying to say is, it's not that it allows you to write anything and execute it and come back and figure out the bugs. It's not, it is not going to work in that way. You are going to write what it is allowed, only that. So, okay, let me push this code and just git add. Okay, so yeah, so we will have class tomorrow also. We'll see the next topic tomorrow. But yeah, so when you get time, just try to uh, work on these use cases what we talked about today. Because as I mentioned, it is pretty important in terms of interview purpose.
One small note: how you are comparing two terminals at the same time?
Okay, I'm not comparing, so I'm just having two terminals open here. So for example, like have a terminal here. So there is an option over here. You can see there is an option to split your terminal.
Okay,
By
split.
doing that, it just creates one more terminal. So okay, so it says it does not exist. So now over here, you can see I have another terminal open. So you can create a number of terminals like this.
Okay, got it.
So there are also this is something which is not possible in VS Code. For example, if I wanted to run command in all the terminals together, for example, I wanted to run ls command in all the terminals. It's not possible in VS Code, but it is possible in other terminal. Like if you are using Mac, there is a tool called Item. So using Item, like you can have open multiple machines into multiple terminals, and you can pass on single command in all the machines. Yeah, I mean, again, since because we are talking about multi-terminal, I'm just saying, but yeah, that's not possible in VS Code.
Hello.
Hello, yes, Ashan.
Sir, I have another question.
Yeah,
Can we use these resources in the load balancers?
of course, yeah.
If
You
there
can
is,
create any resource. Okay, so any cloud resource can be created with help of Terraform, load balancer, auto scaling group, database, Lambda functions, EC2 instance, network, VPC, subnet, security group. Everything is available.
okay, like we create some like two machines using Terraform,
Hmm.
and in the load balancer, like it increases it to number three numbers. So
Mm-hmm.
there will be a difference in the state file, right?
In the auto scaling group, you're saying?
Yes.
In auto scaling group, for example, you whatever desired count you are giving, right? That desired count is something which is which you are finding, right? So the desired count. Okay, so I'll share my screen again. I understand your question. So so you're writing a Terraform code for auto scaling group. Okay, so in your auto scaling group, so you have written a code, and in your code, you have written desired count as 2 and minimum as 1 and maximum as 10. And you created the machine. Now Terraform is going to create the state file to store your auto scaling configuration, not the machine configuration. Okay, so the machine configuration also will be stored, but it will not store like for example, if two machines are created out of this desired configuration desired count, only the two machine count will be captured here. And tomorrow, because of incoming load, the machine number of machine goes from 2 to 10. Again, that's it. That is temporary. That another 8 machines is not going to always stay. When your load comes down, the machine is going to come back to the desired count what you mentioned here. Right, so it is a fluctuating machines, the which is going to get created on demand when there is a load, and not necessarily that need to be captured in the state file, because that machine will be automatically deleted when the load is automatically down.
Okay,
You
sir.
you got
Got
you
it.
got my
Yes, yes, I got it.
yeah.
Thank you.
And that is something what not Terraform is managing. That is managed by auto scaling group. Auto scaling group automatically scale the machine according to your minimum maximum count what you have given, and it is taking care of those things. And nowhere you're going to perform Terraform apply or something to perform those things. That automatically does when the load is increasing, right? So Terraform does not have any control on that. However, we can't track all the new machines which is getting created through Terraform, because it is not done by Terraform, it is done by auto scaling group. And all the new machines, whatever it is getting created, again, those machines are temporary machines, which is created in place to serve the incoming traffic. And those machines will be automatically deleted when the traffic is reduced. And only the two machine will be always running in your cluster, which is what you mentioned in your desired count. Those machines will be anyway, that information will be available in your state file.
Okay, sir. We just have to specify the configuration. Rest all
Right,
will taken care by the AWS.
right, yeah.
Okay, thank you.
All right. So yeah, so today it was pretty productive session. Everybody was asking a lot of questions. Good. So we'll continue tomorrow with the next set of topics.
May I know the remaining topics for Terraform?
So we still have variables to be covered in Terraform, and then we are going to cover credential management. So in all the code, whatever you're seeing right now, the access key and secret keys are hard coded, but that's not a best practice. How in real time credentials are passed down to the configuration file, so that we are going to see. And then we are going to see backend, remote backend, how to use S3 bucket to keep your state file. That is one concept. Another thing is we'll see some examples to create other set of resources. Now, in all the examples, we are doing only EC2 instance, like how you can create security group, how you can create S3 bucket, how you can create VPC subnets. I'll show you some examples on that. I think with that, Terraform is completed. And then we will have some classes on Ansible.
In real time, that access key, that is a one-time work, right?
Yeah, it's one time.
Uh,
So if you ask me how many topics, how many classes pending for Terraform, probably 4 to 5 classes for Terraform only. Okay, yeah. See you tomorrow, guys. Thanks for joining today. Bye-bye.
Thank you. Thank you.